Hello, everyone, and welcome to the robotic classes supported by the project Discovery Robotics via STEM and by the European program of European Union Erasmus+. My name is André Dias. I'm from Portugal, from a company that is called Robotic Academy, as we say in Portugal, Academia de Robotica. And today, I'm going to give the first class where we're going to do the first introduction to Arduino program with software MBlock. I hope everyone enjoy and be able to do these classes in your home or in your school. For starting, let me say what's going to be the topics that we're going to address today. For starting, we're going to explain a little more about the Arduino, introduce to the MBlock software, learn how to program Arduino Uno with MBlock software, explore a little more about the components that like breadboard, LEDs, and resistance, do some experimental tests how to program the Arduino and see the effect in the onboard LED available in the Arduino. And also, we're going to have the opportunity to have two challenges. One challenge that is putting a LED blinking in a breadboard, do a police lights, and then we're going to leave a small challenger for everyone to do in your class. That will be a homework challenger that we're going to challenge everyone to do the traffic lights. But before we start, let me say what type of material that you need to have available to do this tutorial, this class. You need to have a microcontroller Arduino Uno, and of course, the USB cable to programming the Arduino. 3 LEDs, one LED red, green, and another yellow. 3 resistance of 330 ohms, a breadboard, and don't forget also to install the MBlock software. That is, the link is going to be available in the YouTube description. So down, you're going to see in the description of YouTube the link to make download of MBlock software that you need to have for the classes. And let's start it. For now, let me explain a little more about the microcontroller Arduino. Microcontroller Arduino is a device that allows the students to explore some sensors and actuators in robotics. It's a microcontroller that was designed for the students to explore this world that at the beginning was not easy, and the robotic community decided to develop a device that is called Arduino that allowed the students to have a good interface to develop new skills and explore some topics of STEM. For starting, let me say that Arduino is composed by a microcontroller that is here, that is called microcontroller from Atmel, and it's a microcontroller that of 8 bits. I'm not going to go in detail about this, but if you have any doubt or want to know a little more, I am available to answer to these questions by email. So be free to contact me as you wish. But let me explain a little more about the interfaces that are available in the microcontroller Arduino. In your right side, you can see in green some GPIO pins. That is, GPIO means pins for input and output, and are pins that are going to allow you to interface with some sensors and also with some components like LEDs. In your left, you have in yellow some analog inputs. The analog inputs are it's an important part to connect to sensors and allow us to receive analog signals. I'm going to explain a little more in the next class, not today, but just to know that the analog are a good way to receive information from sensors. But in the future, we're going to detail a little more about that. And also in green, in red and black, you have available the power supply that Arduino provides. The Arduino is connected by a USB cable here, and that USB cable provides 5 volts that are available here in this connector. You have 5 volts and 3.3 volts that allow you to connect this power to sensors and actuators that you want to use it. As I said in the beginning, the goal of today is to explain how to use Arduino with the software MBlock. The software MBlock was a software that was developed by a company that is called MBlock, and is a software that allows you to have a programming by blocks and a feasible way to programming and debugging the code that you are doing for the Arduino. But now it's better to see how it used by connecting to the software. In your right, as you can see here, I opened the MBlock software. And as you can see, the MBlock software is composed by 3 areas. One area that is the stage, where we can have some interaction with this sprite that is called Panda. This is not going to be very useful today, but just to know that you can have some interaction between Arduino and the sprite Panda. In the middle, you can see here some blocks. And one of the most important blocks that you have here is the robots, where you have the Arduino blocks that we're going to explore today. And this will be the part of the code that you're going to send to Arduino. It has blocks here, blocks like forever, events, sensing, but most important is the robots, where we have some interactions that we can do with the Arduino. To communicate with Arduino, we need also to do one step, that is connect. You need to come here, serial port, and choose the correct device that is connected to Arduino, okay? And also, you need to define here in the boards that the device that you are using in MBlock is Arduino Uno. As you can see, the MBlock provides different support to different types of Arduino. Arduino Uno, Leonardo, Nano, Mega, and Mega 2560, okay? In our case, we're going to use Arduino Uno, okay? So now, next step is connect to Arduino. So if you already have connected the USB cable to your computer, now if you come here to connect, you're going to see that it's going to have a new device different from previously. As you can see now, there is a COM12. I'm going to connect to COM12. If you connect, you're going to see 2 changes. One changes here in the top, you see that the serial port says connected. And also, when you are in robots and you are seeing Arduino, you see that these lights change from red to green. This means that now you are connected to Arduino. To program in the Arduino, you're going to have here an interface, an area where you can drag and drop the blocks. The first and most important block is the Arduino program block, okay? But now, let's switch to the real Arduino to discuss a little more about the hardware, okay? The hardware here in your right, as you can see, is composed by the Arduino, and as you can see, is already in the breadboard. Don't worry about the breadboard for now, just focus in the Arduino. The Arduino has available here, in this point, onboard LED. This onboard LED is connected to a pin that is called pin 13. So just to check if you are able to communicate with Arduino and able to send an initial code to Arduino, we're going to do the following. We're going to implement in MBlock the LED blinking in pin 13. How we can do it? First, as you can see, we need to put Arduino program here. Then we need to implement the loop forever. And the loop forever is done by having this block that is called forever. This means that everything that is going to happen inside is going to be performed forever, continuously. So if you want to do LED blinking, what we need to do? We need to turn on the LED and turn off the LED. To turn on the LED, we need to use the instruction set digital pin 13 to I. When we do this step, we are turning on the LED. But if we want to turn off the LED, we need to duplicate this instruction and put low. This means that is doing I, turn on the LED, and after low. Continuously in forever. One thing that you must know is that if you put this in your Arduino, what is going to happen? Any idea? Let me give you some clue. The impact is that the LED, the Arduino is going to do what you programming here, is putting the pin 13 on and off, light, high and low. Is putting the LED high and low continuously. But it will be so fast that you don't going to see the impact of high and low. To make sure that you are able to see the turn on and off of the LED, we need to have a wait time between the instruction high and low. This code is correct or is missing something? Let me do step by step with you. Forever. This means that it's going to be forever. And we are putting LED 13 high. Wait 1 second and put in LED low. And in the same instant, I'm going again to high. What this means? This means that the LED is going to change from high to low. But when it's in low, it's going again to high without waiting. This means that you need to have the same instruction here below to make sure that the LED is able to be 1 second on and 1 second off. Okay? Now it's time to send this code to Arduino. And what is the correct procedure? There are 2 ways. One way is pressing your mouse in the right mouse and do upload to Arduino here. Okay, and now appears a new window where with instruction upload to Arduino. Okay, or if you want to do in a different way, you can come here and choose Arduino mode. When you choose here Arduino mode, it opens here the window that I showed previously. In my opinion, it's better to do like this. Press in the right button of the mouse and choose the option upload to Arduino. And when you choose, you can start by upload to Arduino. If everything is okay, it's going to see in here in your right that is compiling the code. Okay. It says, okay, thank you, and says upload finish. At this moment, it happens to change. The code is already running in the Arduino, and Arduino has disconnected from your software MBlock. This means that in the next time that you want to upload the code to Arduino, you need to come here again to do connect and choose again the COM that is with respect to Arduino. Let's check if the LED start blinking. Let's see. As you can see here, the pin 13 is already blinking, as I said, okay? The pin 13 is here, is doing LED on, LED off, LED on, LED off. Let's change the volume from 1 second to 0.5 seconds and see the impact. 0.5 and 0.5. Don't forget, connect again to COM12 in my case. Says connected and upload to Arduino. What is expect to see? The LED blinking faster or slowly? Faster. Let's check. As you can see, the LED now is blinking in fast mode, like in fast mode. Is faster than previous. Is in 0.5 seconds is blinking from high to low, from on to off. Okay? Any doubts? I hope everyone is able to follow the code, the instructions. But if you have any doubt, you can move the video back and see again, make some pause and see what you need to change or to make sure that the code or the hardware is working correctly. Now it's time to jump again to our slides. As you can see, we are able to do this. Just an overview. As you can see, we have done this step, making the onboard LED of Arduino blinking. That is the pin 13. And now the next challenger is to explore the physical LED and do in breadboard one assembler that allows us to do the same that we are doing on board LED, but with LEDs outside of Arduino. For starting, let me review with you what is a LED. As you can see, the LED, as the word says, means light emitting diode. It's a component that if you apply positive value in this pin that is higher leg, has a high leg, is the positive pin, and the minus is the short leg. This means that if you apply positive value on this side and negative value in this side, the LED will turn on. Okay? So, and what is a breadboard? Now that we already know what is a LED, let's check what is a breadboard, just to remind what has already been explained in previous videos. The breadboard is a board, as the word says, that is composed by holes, and that holes are connected to each other. This type of device this type of board allow us to make some electronic circuits because it allows us to connect each component to each other. As you can see, in the middle, the holes are common in column, and in the corners, the holes are connected in line. So let's see how we can assemble a LED to turn on. The first step is to provide to the breadboard the power supply. In this case, we're going to put 5 volts in the red line. This means that, as I said before, the 5 volts, the power supply, is going to be available in all these holes, okay? And the GNG, the negative value, will be available in these holes here inside. Next step is to assemble the LED. As you can see, the LED, the short leg is in the left side, and the positive LED is in the right side. So where we should connect the positive? To this one. Let's see. First, we need to add a resistance. I haven't discussed what is a resistance, but in previous slide, this already been discussed. But just to remember, the resistance is a component that allows us to limit the amount of current that is sent to the LED. This will allow the LED to be protected from too much current in their circuit and stop working, okay? So if you put the LED, the resistance here in the negative, the pin that we need to connect here to the negative is here in this column, okay? As you can see here. So just to remind, just to refresh the ideas, we have here the positive. So the positive power is available here. We are connecting from this point to this point the do the power supply, and then we have the resistance here connected to negative. If you power on the Arduino USB, the effect will be that the LED is going to turn on. Let's see if it's true or not. Okay. Let's see. Let's do it what we have explained. So we have here the positive pin. Okay. We're going to turn to the line positive here. The negative pin here is connected to the negative. And then we're going to put the resistance. Yeah. And to make sure that we follow the same that we have done there, we're going to connect the positive pin, the negative pin, to the resistance, and the other is going to be elevated. Okay, so the positive pin, the positive pin of LED is connected to the positive. Okay, and the negative pin is connected to the negative. And as you can see, the LED is turned off. Okay? If you have any doubt, you can do it again by putting the video back and check if everything is okay. Back again to the slides. Back again to the slides. The next step is to do the same, but with the, as you can see, the LED is continuous on. If you want to do the LED blinking, what we need to do? We need to use Arduino to do this step, to change the LED from on to off in the same way that we have done with the onboard LED available in the Arduino. So to do that, what we're going to do? We're going to change the positive line that was connected to this point. We're going to change from being connected to pin to connected to the positive, and we're going to connect to pin number 9 here. Let's do this step. Okay? How we can do it? We're going to disconnect the cable, and we're going to use a green cable just to make sure that the colors are the same that we are using in the slides. So we're going to connect this cable here to pin number 9. Okay? As you can see, at this moment, the LED is off. Okay? But to make sure that the LED is blinking in the same way that we're going to have here the LED 13 blinking, I'm going to change in the code here from pin 13 to pin number 9. Okay? Don't forget, connect to Arduino and perform upload to Arduino. Okay, as we expect, with this code performer. What we see is that the pin number 9 that is connected to this LED is blinking in the same way that we define in the code at 0.5 seconds. But if you want to see the difference, if you come here and change from 0.5 to, for example, 3 seconds, and connect again, you can see that the LED is blinking with 3 seconds on and 3 seconds off. Okay. I hope everyone was able to follow. Let's go for the next challenge. Now that we are able to conclude the previous work where we are able to blink the red LED, the next challenge is to do the same, but with a blue LED. So to do that, we're going to call the police lights. So the idea is to have an alternative blinking. First, while the LED red is on, we need to have the blue LED off. And alternatively, when we turn off the red LED, we need to turn on the blue LED. So for starting, let's assembling the circuit as you can see here in the figure. So we're going to duplicate the same schematic, but now from the LED red to LED blue. And make sure that we're going to have a cable that connects not to pin number 9 like is connected to LED red, but to pin number 10. So let's do it. So looking here to the circuit, we need to have a resistance in the same way that we connect it here. Okay. The resistance, one side of resistance is connected to the negative GND here, okay? And now we're going to have the blue LED. If you don't have a blue LED, you can use another type of color, but if you have, it will be nice to have this type of colors. And the positive pin, that is this one, is going to be here. So the negative is connected directly to the resistance. And now the positive one from LED will be connected to pin number 10. Okay. Okay, let's jump to the code and see what is happening. So as you can see here, we have the previous assembly, we have only the pin 9 blinking, pin high and low. So for starting, we need to duplicate this one and add here pin number 10. Okay. Wait some time and duplicate. And what we need to do it? When, as you remember, I said that when pin number 9 is high, that is the pin connected to the LED red, we need that pin number 10 being low to make sure that the blue LED is off. After 1 second, for example, we want the alternative assembler. So 9 must be low and 10 must be high. So we wait 1 second. And what we are doing here is blinking between red LED on and blue LED off. And then the opposite, the blue red on and the red LED off. Don't forget, connect to Arduino and upload the code. Let's see if it's working. As you can see here in the image, in the video, you can see that both LEDs are blinking in the alternative way. Red, blue, blue, red has the police lights. If you want to change the velocity and increase with more, don't forget, connect and upload. Okay, by changing the waiting time, you increase the switch between red and blue, and they become faster. Okay. I hope everyone was able to follow. Homework, as I said before, for each class, I'm going to give you some challenger to do in your classroom or to do in your home. So the challenger for these classes is to do the traffic light. So I provide here what you need to assemble. You need to use 3 lights, and the goal is to implement a traffic light. So we need to make sure that the red LED is on for 5 seconds. The LED green needs to be on for 10 seconds. And the LED yellow must be on by 5 seconds, but while it's on, needs to blink at each 0.5 seconds. So feel free to think, to see how to implement, and if you have any doubt, send me an email that I can help you. What are the doubts that you have? Okay? I hope everyone enjoy these classes. And as I said before, if you have any doubt, I provide here my email to make sure that everyone is able to contact me and interact with any type of question that you have. Thank you, everyone, and see you next time.